An update for Big G. The strength of gravity was just measured more reliably than ever before. But still, it deviates a bit from previous consensus. How haven't we figured out such a basic thing as gravity yet? It's been about 230 years since Henry Cavendish used an incredibly sensitive torsion balance to measure how two small spheres were pulled sideways by bigger lead spheres. For the first time, he derived the gravitational constant, Big G. Since then, physics has come quite a long way. We've discovered relativity, quantum physics, subatomic particles, and a lot more. How is it possible that there's still uncertainty about gravity? For starters, gravity is the weakest among the fundamental forces. Take magnetism for example. Even a tiny magnet the size of a pin's head can lift a paperclip off the floor, overpowering the gravitational pull of the entire mass of planet Earth. Also, gravity has quite a heavy influence on our environment, so it's much harder to isolate the effect in a lab setting. The masses you would experiment with are tiny compared to Earth, and so is their mutual gravitational attraction. Everything around is stronger than this effect, even tiny air currents or temperature fluctuations. That's why physicist Stephan Schlamminger and his team at the US National Institute of Standards and Technology spent a decade on the most rigorous attempt to measure Big G yet. Surprisingly, they still use the same principle Henry Cavendish used, a torsion balance, just a much refined one. They measured the gravitational pull between 8 precisely calibrated masses using 2 completely independent methods. Then they repeated the whole experiment with sapphire masses instead of copper, to rule out any material-dependent effects. To avoid unconscious bias during the analysis, Schlamminger even had a colleague scramble the data, so he wouldn't recognize if their result was close to the accepted value. In the end, their result came in at 6.67387 plus or minus 0.00038 times 10 to the minus 11th cubic meters per kilogram per square second, which is slightly lower than the current global reference value, but still within the range of the reported uncertainties. Does this mean you need to readjust your bathroom scale? No, you are still